Hi, my name is Cameron Dutro, and I'd like to take the opportunity to showcase something that I've been working on for about a year now. It's a bunch of experiments and ideas around how to change how we do front end development in Ruby on Rails. One of the big sort of parts of this is to make more the Rails front end more reactive, provide opportunities for CSS streamlining, so CSS modules and whatnot, and also all sort of wrapped in a component framework like you might see in Vue Component or React. So let's dive right in. I also recorded a longer form video that was really long, and I'd like to make a shorter version. That's what this is right here. So we're not going to go into actually how to use this thing. It's also not published anywhere. This is just my own sort of musings about it. But yeah, this will be just a short form video content or short term form video of the same content, and you can watch the longer version later. Also, if you want, I'll link that in the description. So yeah, let's dive in real quick and just I'll describe what this is and sort of why I'm trying to go down this road. So we're all familiar with React. We all know that React kind of eating the world of front-end development, and rightly so. React is awesome. TypeScript is great along with it. You can move pretty quickly, but there's still a lot of overhead, a lot of ceremony with React. And what I'm trying to do, there's also I think a lot of discontinuity between going from your Rails backend to your Rails front end and not really having the same seamless experience over there that you might have on the back end. So yeah, let's dive in. What I've been doing is working on this little test app. This is called Crosswise. It's just a crossword puzzle solver. It's a mini crossword puzzle solver specifically, and it's designed to work sort of like the way that the Apple one works in the Apple News app. You also notice that this is the name of the app is actually To-Do List too, because this did not start as a crossword app. I was just again playing around, messing around, and lots of this is just experimental. The names are not quite right, but hopefully you get the gist. So the way this app works, I can show you is if I'm here in the app and I type the letter T, my timer starts to go, and this first clue is number of fingers and a peace sign. So that's TWO. Get a grip is the next clue, and as I'm typing, it's filling in these characters in the squares. On the lookout, alert. Bit of DNA is a gene. It comes to a closes, ends. And then we got a little bit of a nice confetti animation at the end, and you can see the stopwatch stopped here. So that's the app, and would you believe that this entire thing was written in Ruby? Well, you might not, and that's actually not quite true. Some of it's written in JavaScript. Most of it, though, I'd say 99% of it is written in Ruby. It uses the Opal JavaScript transpiler to do most of that heavy lifting. So we take Ruby code, transpile it into Opal, and then the reactive portions are built using Solid.js, which is a much more lightweight and less computationally intensive framework for rendering views in reactive views in JavaScript. So with these two things combined, we get what I'm calling Neato, but I think I'll have to change that name at some point. So that's the app. Let's dive into some of the code behind this. So we're just running a Rails server here. I've got a Vite server, or a recompiler, I guess you'd say, a dev server, and also I'm running a watch command from PostCSS. Okay, so here's our game component. This is the main component in the application. It includes this module called Neato component. And right away you can see sort of the reactive nature of this whole thing showing up. So we have our initialize method here, and there's a set state call. So just like you might have in a React component, Neato lets you set state and then get that state later. There's also every prop that you pass into a component is also reactive. So if it changes, the view will automatically re-render. I say re-render. In Solid, there's actually not really the concept of re-rendering. Your view renders once, and Solid attaches listeners and whatnot in strategic places to update the view. So that's how it gains most of its speed advantage over React, is that it doesn't actually re-render anything. It just updates the view as you would expect it to do based on reactive properties, but does not re-render the entire thing. You also can see right here that I've got what looks like just HTML in my Ruby code. This is actually from another gem that I wrote a couple years ago called Rux. Rux is JSX for Ruby, and you can tell that I've also got a VS Code extension that gives you Rux syntax highlighting. I can stick Ruby code inside my HTML just like you can do in JSX with JavaScript. And I've got some components at play here. There's a board component. This is where a lot of the magic happens. There's got a couple of callbacks. Notice that I'm literally just passing Ruby lambdas here, and there's an on square filled callback function that I've defined here on my component, and I can set the state and do a bunch of other nice things as you might expect in a normal Ruby component class. But of course, every time one of these, like for example, when status changes, then the view will be updated automatically as a result. We've got some components here that also sort of like to showcase. Stack is just kind of a custom implementation of like a wrapper around the Flexbox CSS structure or CSS feature. There's a label component, it's a wrapper around the label element. There's a stopwatch and a pause button component here. And these stopwatches, by the way, are what you're seeing here on the right-hand side of the grid. So one example that the longer presentation covered implementing stopwatch. I'm not going to do that now, but I can sort of go over some of the cool reactive properties that we're taking advantage of here to get the pause button and the stopwatch working. So you can see that there's a running property here. If I pass true here, then the stopwatch will start. If I say running is false, then the stopwatch will stop counting up. And when we set our state here, we set the status to running, and then we alias the running status, like we have a running method here, and that checks to see if the status is running, returns true or false, and that's what gets passed in here. The pause button, of course, just does the opposite of that. There's a pause function here, and or pause method rather, and that just sets the state back to idle. So there's the reactive sort of side of this is sort of really on display here. If we look at our stopwatch component, we have stopwatch.rux. What's happening here, we have a props on change that's actually doing the heavy lifting here. Props on change will fire every time the props that are passed into this stopwatch component change. We have a tick method, or tick lambda rather here, and on every time this is called, it updates the elapsed number of milliseconds, increases it by 100, and then here we're actually using the backticks that Opal gives us to stick this literal bit of JavaScript into the code at this point, and we set interval and call the tick function every 100 milliseconds, and then down here we're also clearing that interval when we're not running anymore. The template here is not super important, but what I will point out is that we're also taking advantage of Neato's built-in CSS module support. So there's a stopwatch.module.css sidecar file here. This contains a stopwatch class, and what I can do is say styles.stopwatch. That dot method right there is directly extracted and made available because the stopwatch module CSS file has a class called stopwatch on it. So, and then of course a bunch of other nice helper methods down here. So one last thing I will point out, and we can see this not only in stopwatch, it says renders on client. So this stopwatch code is only renderable on the client. And that's because, of course, it uses JavaScript functionality you can't get on the server side. We also have where's my stack component? There it is. Stack can render on both client and server. So there's a way to sort of differentiate components and where they render, because most of the time on most websites, most content is static, but you can also render little bits of content here and there that are dynamic, and that's kind of maybe the sweet spot that the Neato is trying to target. If we look at the HTML behind this page, we can see that what we're doing here is actually rendering this thing called an island, Neato island, which is a custom element. We're passing in some Ruby data here, so that sort of gives us, more or less nice a nice mechanism for passing data from Ruby to JavaScript and potentially back and forth there. And then this whole thing inside the island was rendered by solid.js. And you can see that let's refresh the page and reset the puzzle. And as I type, I'll just expand this so we can see all of the squares and whatnot here. As I type here, you can see, and as I click, and it's changing which squares are active and which direction I'm typing. You can see that it's adding and removing classes dynamically, and that's all sort of declared inside the component. And there's not a bunch of like manual find this element, change its class like you might see in Stimulus or in jQuery world. Okay, so that pretty much covers it. I'm really curious to hear your feedback, and I'd love to hear your both your constructive criticism and your praise. The constructive criticism, of course, being the most valuable part of this whole thing. You can get in touch with me. I am on Mastodon, ruby.social. You can go look at my username here, ruby.social@cameratron. And I'm also available just via GitHub and yeah, mostly via Mastodon. So thanks everybody, and talk to you soon.